This is laundry room of our house, and this is the trap door that leads down to the crawl space slash mechanical room. Anyway, this is the access and the only access down there. So over the years, like it's become quite heavy for me to lift and my wife. We're getting older, and I had hip replacement done earlier this summer, and she had to go down there and reset the well pump pressure switch. So she had a heck of a time. This is the little latch for it here. You just pull up on it. But the whole thing weighs about 100 pounds, and it's hard. It's difficult with that washer in the way and that to do. So I've been wondering about motorizing it for years, and decided to do it after that. So I did it. Now these two little screws here are where one of the ends of the actuator mount to. And for an emergency situation, I put in these socket head, they're called socket head cap screws. And you just unscrew these two little bolts here, and then the door will come up and the actuator isn't coupled to the door anymore. So that's a safety feature I put for just in case there's a power outage or whatever reason you have to get down there manually. So anyway, I'll show you how it works. This is an outfit called, I think it's called Progressive Automations, and they specialize in linear actuators for all kinds of applications. Anyway, the model I got comes with this little wireless remote fob here. It actually comes with two of them. And we'll show you how it works here. Push the up button. Up she goes. It's a limit switch and stops. Let's go down here and turn the light on so we can see better. Give you a little show and tell about it. Okay, so this is the actuator, of course, the motor and the RAM and all that. And so when you order it, you have to, these things come in all kinds of lengths and forces and all this kind of stuff. So you got to figure out what you need. I had to build this mount thing for it, of course, for my application. And so what it comes with is this is the 12-volt power supply, and this is a controller. That's the wireless controller. And of course, this is an actuator. Now this is a standalone external limit switch because in the perfect application, the way it works is you calculate it so that when it's all the way down, there's internal limits on these things. So when it's all the way down, it shuts off, and when it's all the way up, it shuts off. But on the upstroke, mine didn't work out that way, so I had to use this limit switch. On the way down, it worked out perfect. It comes all the way down, and then the lid rests on this ledge here, and it's just perfect that way. But that's what I had to do. Now there's quite a bit to it as far as figuring out what you need. You can imagine the geometry of all this setup here is kind of complicated, critical. This particular actuator is one that has what they call 100 pounds of force. And you can get them, like the other option was a 400-pound force. But the trouble is the 400-pound would have given me more, I wouldn't have needed such a long actuator, but it's like slow. It's like 3 times as slow as this, so I didn't really want that. So I opted for this version here, and it works just fine with that limit switch because it stops it where it needs to stop. Now, of course, if perchance you were down here with the thing closed and you had to get out and, I don't know, say something went wrong anyway. So all you have to do is pull these little spring pins, or one of them, and then you pull out the pin there, and then that frees up the whole apparatus, and you can lift the door with your shoulder, and it's safe that way. So I don't know what else to tell you. It's, as I say, you got to work out this geometry and everything right for that actuator you need. They have this on their webpage, a kind of an actuator, what would you call it, calculator for how it all works. And I tried that, but in mine it didn't seem to work. So I had to do my own calculations. And what I did was, you got to make sure you get the right one because they're fairly expensive. And if you buy it and use it, well, I don't think they take it back. So what I did was I actually have a little air cylinder that I kind of mounted down on these steps here, just temporarily, right about where this is here. And then I went up to where the mount was on the door here and mounted the other end there. And I hooked up my compressor to it. And I just started turning the pressure regulator up till it started to move the door. And it moved it at about 75 pounds. Now, that was like about 30 psi, but you have to do the calculations of how much force you're applying with that amount of psi and the square inches of the piston. So anyway, there's a bit of trade math there, but that's how I did it. So it lifted up there at, at only 75 pounds. So this was 100 pounds, so I thought, well, it should work, and it does. So, but anyway, be very careful. They've got a kind of a tech web thing on it on the website too, this progressive automations, and they're helpful to help you, work your way through it. But that's my only advice is get it right, or you're going to be buying all this expensive hardware for nothing. And you want it to do the job you want it to do. So anyway, I think that's all I got for now, and see if it works for you. My application, it's perfect. It's like I said, that's the only way in and out of that crawl space, and it's a heavy door, so this solved that problem. Okay, bye-bye for now.